Hi, fourth grade. Happy Wednesday. And I just wanted to start off today with some very quick and brief announcements before we continue our metric practice for today. The first thing is that you have done an amazing job these 7 weeks learning and working really hard while we're at home and doing all of the work online. That is nearly 2 months of us taking time away from school to stay home, to stay connected with all of our families, and making sure that we are healthy. That means we are 1 week away until the end of the regular school year, which means next Friday is our last and final day. Sad bear, but the good news is that you can continue to learn online during the summer. So, to start off our announcements, the last day to complete all of our assignments are May 22nd, and that is next Friday. So we have one more full complete week to continue to work really hard, show all of your Vista Core values, and complete all of those assignments from your Google Classrooms and even your Lexia minutes. The good news is that we have a summer session, which is super exciting. That summer session is going to start June 3rd and it's going to end June 26th. So truly, it is the entire month of June. What that would look like is that would be one guided reading group a day, every day for the whole entire week. There might be an opportunity for some math. There will be 4 times throughout the day, which is 9 a.m., 10 a.m., 1 p.m., and 2 p.m. You might receive a call asking to be invited to summer school to see if you are interested. Not all students will be asked, but if you are definitely interested in summer school, that would be so amazing if we got you to sign up and you continue to do some guided reading over the summer. So again, you might be receiving some phone calls this week or next week inviting you to summer school. Because we only have one more week of school, we're going to do some more fun activities. And one activity I'm already thinking, which some of you may or may not have asked for, which is something that's called origami. And I'm really excited to be able to do some of those things with you guys because it is so related to math. And as you can see, over here, this really cool GIF over here is basically what origami is. It's taking a single sheet or even multiple sheets of paper and folding it into a really amazing piece of art. This one, super amazing. We are not going to do that rhinoceros, but we're going to do some other really cool things instead. So see that either at the end of this week or start the next week. So be sure you watch the whole video. Let's go ahead and continue for our guided practice for today on metric units of length. It'll be pretty brief, so be sure you have pen, pencil, paper, marker, crayon ready to go. Welcome to the guided practice, friends. So today we're going to work on something that we kind of worked on yesterday's guided practice as well as the independent practice, which is converting. Converting basically means that you take smaller units into a larger unit or even a larger unit into a smaller unit. One example that we actually use all the time is money. Very rarely do any of us want to carry a whole bunch of change in our pocket. So because of that, we convert that change into bills, sometimes even dollar bills, $5 bills, $10 bills. And the only way that we can do that is that we have to have an equivalent amount of coins to make those dollar bills. And we can do that with 4 quarters, 10 dimes, or even 100 pennies. The same thing is for the same thing applies for measuring. We would not use millimeters or even centimeters to measure the length of a football field. That would be thousands, if not tens of thousands of millimeters and centimeters to measure. And those numbers are simply just too large to help consistently keep track of. So mathematicians and scientists came up with larger units, so in that way we could measure larger things. So in the instance of the football field, we would measure it in meters. Well, we can then figure out how many centimeters are in those meters. Let's see an example in a story problem. The first story problem says, Jason rode his bike 1 kilometer, 850 meters. This was 529 meters less than Allison. How many meters did Allison ride her bike? So you'll notice that Jason rode his bike 1 kilometer, 850 meters. That's in mixed units. That's right, mixed units. What a mixed unit just means is that it is showing the kilometers and the meters that were measured. So what this means is that Jason rode over 1 kilometer. So the mixed units are kilometers and meters. It's kind of like a mixed number, where you see a whole number and a fraction. We also know that this amount is less than what Allison rode her bike for. So what that means is that Jason rode his bike a shorter distance than Allison. And the evidence from the story is Jason rode his bike 1 kilometer, 850 meters. This, as in this value, was 529 meters less than Allison. So then the question wants us to figure out how many meters did Allison ride her bike? Well, if this value is less than the amount that Allison rode her bike for, how should we figure out how many meters Allison rode her bike? Well, one way that we could think about it is that we can add the 529 meters to the 1 kilometer and 850 meters. And the reason that we might want to do this is because, again, the story says that this value that Jason rode was less than Allison. When we add these values together, we have to keep the same units together, which means we cannot add this 1 to 850. We can't add 1 because 1 is representing the kilometers. 850 is representing the meters. So we can combine the values of the meters. So when we combine 850 and 529, we can start with adding the hundreds. So 800 plus 500 is 1,300. Then we can add the tens and the ones. Well, 50 plus 29 is 79. When we add 1,379, we get 1,379. And remember, that was representing meters. So when we combine the meters together, we now have 1 kilometer, 1,379 meters. Well, the question's asking how many meters did Allison ride her bike? Which means we need to express our answer only using one unit. You might have noticed at the top of our form, there was a chart that helped us with some of that information. Find the information on the chart that shows How many meters is equivalent to 1 kilometer? Well, the chart shows that 1 kilometer is equivalent to 1,000 meters. Hopefully, you've remembered that the prefix kilo represents 1,000. Now that we've converted the kilometers to meters, we can now combine these units. We can combine them because they are now the same units. So 1,000 meters plus 1,379 meters is equal to 2,379 meters. And again, since the question's asking us to express it in meters, we can simply type in our answer as 2,379 meters. Cool. Now with question number 2, the same skill is going to apply. We're going to convert the centimeters into a larger unit. So number 2 says 429 centimeters is blank 29 centimeters. So again, using the information from the chart, we need to figure out how many centimeters can be made into a larger unit. Well, the next larger unit after centimeters is meters. So look at the chart to see how many meters is equal to a certain number of centimeters. So identify if we have enough centimeters to make 1 meter. When you looked at the chart, you probably noticed that 1 meter equals 100 centimeters. Well, if we know that 1 meter is equal to 100 centimeters, 2 meters would be equal to 200 centimeters. Now we can continue to follow that pattern. So when we look at the value 429 centimeters, and then in our question we have a blank with 29 centimeters, what it's really asking us to find is if there are any meters in 429 centimeters. So again, continuing the pattern, we would then know that 4 meters is equal to 400 centimeters. So when we type our answer in the blank space, what we're going to type in is 4 meters. Let me highlight that. So 429 centimeters is basically the same exact thing as 4 meters and those 29 centimeters. Pretty easy. Continue to use the chart to help you with your independent practice questions. Your first set of questions will be on some information about metric lengths. Pay very close attention and read those questions carefully. If you need to, you can look at the BrainPop videos from yesterday and from Monday. And before I go, I wanted to show you some really fun and cool examples of some origami that I have made or some of my friends have made. Here's one. Woo! Pretty spiffy, right? This one I made. Look at this one. Let me go over this way. I think this one took like 18 pieces of paper. Here's like one of my other favorites. Look at this one. And then the last and shiny one. Yeah. It's Pretty incredible, right? These ones are like super hard, but we'll do some pretty cool and neat ones together. And if you don't have origami paper, that's totally okay. Kitty Badger. If you don't have any origami paper, that is totally okay. I will show you how to take a regular piece of paper and turn it into a square piece of paper so that we can use it to fold really cool things. Be sure to continue to do all your work for this week. See you later.